A few minutes ago, I started looking at an algorithm to be able to evaluate some numbers. So basically, that is what I was doing before we got disconnected. So first of all, the algorithm said you have a value called first, a variable called first, another variable called second, and then the next is always adding first plus second. So I went through it and I got these values. So I keep on doing it till I got the condition that when the value is bigger than, is less than 200, continue. So I have evaluated this till I got a value less than 200. Immediately I got a value greater than 200, I stop. Now, so based on what I have right now, if I type this sequence of numbers, 2, 3, 5, 8, 13, 21, 34, all the way up to this in Wolfram Alpha, which I have just shared, I was sharing the screen with you a few minutes ago. This is Wolfram Alpha, okay? So a few minutes ago, I typed the sequence of numbers here. These are the sequence of numbers. Place a dot around it. And then you ask Wolfram Alpha to tell you what this is. You go down, it will tell you that this is, it says that this is actually a sequence of numbers. You see that it's giving you those sequence of numbers. This is how it is. There's the formula to generate it. But we want the name. The name here is called what? Fibonacci series or Fibonacci numbers. Okay. So all I'm asking you to do is you take your time and then go through these algorithm questions which I have given you as a group question. I've sent it to your class rep. If you don't have it, just ask your class rep. Okay. Just trying to identify where my group questions are. So whether you are in group 1 or you are in group 2 or you are in group 3, pick your group question, answer them. Okay, this is the group questions I'm talking about. So for example, this group question on algorithm. I have done this in the video. I haven't done group 2, I haven't done group 3, but I just done group 4. Okay, when you take the group question, first of all, identify how many assignment statements are in the problem. Okay, and in my, I'm seeing some questions. Let me see what. Hello, sir, please, is a new class. Please start over, please. Sir, please, this is a new class, group B. Yes, I started a few minutes ago, and this is the second video. Okay, so we started at, I think, 12:10 or so. Or if you are now joining us, this is a continuation of the second group B class. So this one, please, just follow as we go on. I will share the video. The first part will be in a video you can watch. I'm sorry you joined in late. We started at 12:10. Okay, so I'm saying that when you have a question like this, you are supposed to write an algorithm to compute the squares of numbers. It has already been written. That is the algorithm you see here. Okay. Now, all you need to do is to try and answer the questions I have here. Find out how many assignment statements are in the problem. Now, in this question, assignment statement is this symbol. I've already explained what this is, this symbol. And based on the rule, you count them 1, 2, 3, 4. So in your answer presentation, you tell me assignment statement is 4. Then how many variables? The variables are the expressions on the left. So if you pick this expression, sum assign a value 0, this name here is a variable. This expression here, I, is a variable. This expression here, J, is a variable. So when you come to your solution, you tell me that assignment statements are 4, but the variables are this 3, sum I and J. How many constraints are there? And up here, I said, what are the constraints? They are what to tell you how long the algorithm will run. And the algorithm will run when you identify the iterative statement. This is the iterative statement for I running from 1 to n. And the problem, I said, trace this algorithm when n is equal to 8. So it means that this problem will run, when n is equal to 8. So it will continue doing this till you get to I is equal to 8, and then it will stop. So it means that my constraint is I is equal to n is equal to 8. And then the last part says that draw the table of output. That is what I was doing in the Excel. Your table will be made up of the variables and then the constraints. So sum I and J. Then you go through each line of the algorithm. Sum is given 0, you enter it into the table. I is given the value 1, you enter into the table. Compute the value j, enter into the table. Then compute the new value of sum, enter into the table. Continue till you've done that for I is equal to 8. I've done this for I from 1, 2, 3, and 4. Continue to 8. And then you finish, you realize that you get an output. Now take this output of sum, put it in Wolfram Alpha. I've explained it here. What does the algorithm do? Take your output of your output, put it in Wolfram Alpha, and that will tell you what the algorithm is doing. So all I expect from you is to go through these questions and be able to give me what these algorithms are doing. It will give you a sequence of numbers, and then you tell me what are these sequence of numbers, what are they doing, what are their expressions. Okay, any question specifically? If you have any question you want me to go over, let me know, or else I'll just go through the rest of the PowerPoint. Yes, what is your question?
Yeah, I'm in group 8, the B question. I'm a bit confused on how to do it. So could you please?
Which question specifically?
Group 8, the group 8 question, it's the B.
Okay, your class rep to drew my attention to it. Please, those who are solving questions from, I think, group 7, group 6, group 7, group 8, these questions or this particular algorithm can be found in Kenneth Rosen. The answers are in Kenneth Rosen. I'm not saying go and copy. Okay, but you're asking me for the B part. It says write an algorithm that takes an input of list of integers and find the location of the last even integer and list or return 0 if there are no even integers in the list. Okay, so I'm saying that you can find out the origin of this question. It's in Kenneth Rosen.
Okay.
I'm coming. Somebody's asking, please, any YouTube link, if possible, we will start from scratch. Yes, there'll be a YouTube link, and I've already shared this with your class rep. Okay, so whatever we'll do, I'll give the links to your rep, and you can watch the video. Sir, please, question 10. Somebody says, sir, please, question 11. Please, that's what I'm saying. Question 7, 8, 9, 10, group questions. They can be found in Kenneth Rosen. And there's a reason why these group questions, I haven't written them. They've not been written. But I want to find out whether, based on what we have done so far or what you watch in my video, you can do something about it. Now, this gentleman is asking me about group B. I can't answer everything here, but I can give you an idea of what they're asking you to do. First of all, they're asking you write an algorithm to list n integers. The first thing you must ask yourself is this. So I'm writing here. I hope you can see my screen. What is an integer?
A
Okay.
positive whole number.
Thank you. So it means that if you went through my algorithm, there is a particular syntax that deals with conditions. Remember, integers are positive whole numbers, positive and negative whole numbers, including 0. I hope you know that. Okay, so if you are listing them, you are talking about -4, -3, -2, -1. Then you have 0, you have 1, you have 2, you have 3, you have 4, all the way up to infinity. Now, so back to the question. It says that write an algorithm that would take an input of n list of integers and find the location of the last even integer in the list or return 0. Now, it says the last even integer. What are even numbers? So the next question you must ask yourself, what is an even number? What is an even number?
Numbers that can be divisible by 2 without a remainder.
Okay, so numbers divisible by 2. I'm not saying you have to do this in your presentation. I'm trying to explain. This divisible by 2, okay, without a remainder. We know this. Now, so let's pick an integers. Let's say, let me take an example of integers, say 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now let's say that this is your n. This is your variable n. I want this to stay at n. Okay, these are your values of integers. Okay. Now, they're asking you, if you input this n into the algorithm, find out the last one. Remember, this thing is continuing. You can have 11, you can have 12, all the way out to, let's say, 100. I don't know. Your integers are infinite. So they are saying that if I have a sequence of integers, give me the last integer. So what am I supposed to do? First of all, I begin, okay? And then because these integers are increasing, I'm going to set a counter for I, starting from, you will know where you want to start from 1, let's say, to, let's say, n. And please, you must tell me what your n is. I don't know what your n is. Maybe, let's say 10. Okay, I'm saying that up to n, but I'm saying let this be something you will choose. 1 to 10. Now, so the numbers 1 to 10, you are testing which one is an even integer. So the first one you will do is, let's say A1 be assigned the value. First of all, I will check if my I, okay, let me use J. Let J be assigned the value. You said to find an even number, you must check whether the number you've picked is divisible by 2. So if I pick I and I divide it by 2, and the answer I get is answer does not have a remainder, then let J be assigned the value, maybe the first even number. Desmond, I hope you are making sense of what I'm saying. Desmond, are you with
Yes,
me?
sir. Yes.
Yes. So what I'm saying is that, you see, I is going to check, I will take the first value, 1. 1 will be divided by 2. 1 divided by 2 will give me a decimal. So if it gives me, first of all, to check. So I am going to find out. First of all, I'm going to check is if I is divisible by 2, then print it out as even. Let's say print it out as even. Else, then forget about it, something like that. I'm not saying this is what you write, but I'm trying to explain, forget about it. So I'll check 1 divided by 2. Is it even? If it is even, then let that J, if I is divisible by 2 and there's no remainder, then let that J be the first even number. Else, then forget about it. Then I will go to 2. 2 divided by 2. Is it even? Fine. 3 divided by 2. Is it even? So it will keep on checking it till I get to my n. So if my n is 100 and 100 is divisible by 2, then my J is going to be the last value I check. So I just need you to see whether you understand what the problem is saying. Remember, I am not testing you whether you know how to write an algorithm. No. Remember, I said at this stage, we are understanding what an algorithm is, the mathematics behind it. So the question is asking you, first of all, I want to know whether you know what an even number is. Know what an even number is. If you can even explain these two things and tell me how to identify an even number. Look, if I give you, you were in class, I would have given you, if I give you a number like this, 1111111, 444 555 777 888, and let's say 7. Is this an even number? Who can help? This number, is it an even number? This big number here. Is this an even number?
No.
No. How do you know? How do you know? Why were you able to tell
No,
that?
it's not.
Yeah, how do you know that it's not an even number?
Because
Because it ends with 7 and 7 is not
Thank
divisible.
you.
After
So,
you did.
yes. So first of all, you must be able to identify what number you are dealing with. So we are checking whether the last digit. I've written the first part that tells you take a counter that will be checking the values one after the other. But I pick numbers from 1 to 10. What if the numbers you are dealing with is let's say 4 digits long, or 5 digits long, or 6 digits long? Okay, if these are the integers you are dealing with, then all you need to do is check the last digit. Tell the program, check the last digit. Is it divisible by 2? 7 is not divisible by 2. 9 is not divisible by 2. So if it's divisible by 2 and it is the last one in your list, then now that will be your last even number. Okay, so give it a try. And like I said, the result or the answer to this is in Kenneth Rosen. Kenneth Rosen, the answers to the questions are at the back. So look at the, yes, look at the answers of that question. If you still don't understand, you send me a mail and I'll give you I have answers to all these questions, but I just want to find out whether you understand at least what we call the assignment statement, the conditional statement, and then iterative statement, because that is what is used to explain the problem. I'm not interested in whether you can write it or get it correct or wrong. I'm interested in whether you can.
Could you suggest any counter we could use? As you were saying. Any counter, as you were saying, yes.
Yes, I'm using the for to do loop. So for I running from 1 to n, where your n, like I'm saying, can be countable or non-countable. So you keep on using, or you can use A1, A2, A3, anything which will work for, or X1, X2, X3. In algorithm, when you are writing algorithm, you must write something you can make sense of. That's all. So if you can make sense of, and a third party can also read and understand, yes, then it means you have written something that can be executed. Okay, Desmond, I think that is an answer to your question. Any other question? If not, then I'm going to wrap up. I don't have any question in the chat. And last number is 7. Say, please, can you, what is brush through question 10? I think it will be the same as what I'm doing here. Describe an algorithm that makes an input of list of integers non-decreasing. What is non-decreasing? When you say something is non-decreasing, what does it mean?
It doesn't reduce.
It doesn't reduce. So it means that it's rather what? Increasing. So you are looking at an algorithm that is numbers which are increasing and produce a list of all values that occur more than once. Okay, this is easy. Recall that the list of integers is non-decreasing if each integer in the list is at least as large as the previous integer in the list. Oh, okay. This one you are just trying to explain. First of all, you have to assume what, let's say I have a number like 2, 2, 3, 3, 4, 5, 7, 8, 8, 8, 8, something like that. You must understand what the question is asking you first. And I must confess, these problems, I'm trying to find out whether you understand what they're asking you. So first of all, you assume you have a list like this. This is a list. Okay, this is n integers and they are non-decreasing. And you're supposed to produce all the values that occur more than once. So first of all, if I is equal to, let's say I is equal to 2, you check I equals to, let's say I, you say that, let's say I, for I, starting from 1 to n, again, it depends on your value. You are going to check, is I equal to j, let's say I equal to I plus 1. I hope you understand what I'm saying. When I say I plus 1, do you understand? Let's say I equals to 1. My first value will be 2. Oh, my screen. My first value of I is 2. Let's say I, when I pick I is equal to 2. Okay. What will be I plus 1? What will this be equal to? Based on the sequence I have. 3. Oh. So I'm saying that is I equals to I plus 1. If it is equal to, then it will be the first repeated number. Do you understand? You are finding which of these numbers in the sequence are repeating. That's what they are testing you. So all you are going to do is you check I, compare I to I plus 1. If I is equal to I plus 1, then the first repeated number. Then you check I plus 1 equal to I plus 2. You see the counter is increasing. So you keep on saying, checking it. If I is not equal to I plus 1, then it means you drop it. You don't need it. You want the last repeated number. So you go to, so this is I, 2 is I, 3 is I plus 1, 3 is I plus 2, 3 is I plus 3. So if we get here and check here, this one and this one, are they the same? They are not the same. I'm not interested in that. This one and this one, are they the same? They are not. I'm not interested in it. This one and this one, are they the same? I'm not interested in it. Now I come here, 6 and 8, are they the same? No. So I check. This one, 8 is equal to 8. Okay? This one is also equal to this. Then you find the one that has more repetition. Okay? So you keep on increasing your I and compare it to the next value until you are able to tell the one that has a lot of repetition. So I've explained what the algorithm is supposed to do, which is what I'm expecting you to tell me. Look, if you can't write any formal lines of instructions to explain it, if you can explain this in English for me, it's enough. Because remember, I define algorithm series of precise instructions to do something. So if you can explain this in English, step by step, I'm okay with this. Listen, I'm a maths lecturer, I'm not a programming lecturer. So I'm not here marking correct sentences. I'm here trying to check whether people can make logic or meaning of an explanation of something which is taking place. Basically, that's what I'm testing. So don't be too bogged down by and say, what does this mean? I really want to find out whether these things you are seeing here, you understand them. For example, if I ask you, what is a median? What is a median? Not everybody knows what a median is. I'm telling you. Okay, so take your time and go through them. If you still have challenges, let me know. I will just show you where you can find the solutions. But I would prefer if you can try it, and then we can all learn from some of the things you bring along. Okay, any other question?
For more information and also to reach us, please contact the numbers on the screen. You can also reach us through our social media handles displayed on the screen. Please do like, follow, and subscribe to our social media handles. A Softek IT Consult. Innovative solutions with the difference.